Good morning, good afternoon, good evening, whenever you may be. Hey, it's another exciting day of 8th grade science live from the front of bunker, somewhere in Mr. Clean's classroom, deep in the heart of the quarantined Southeast United States. All right, so we got another great day of science leading up to you. All right, so a couple notes, a little bit of housekeeping here real quick before we get going. Number one, all right, so this is like the last lesson day of this unit of 8.E.1. So today's Tuesday, so Wednesday, Thursday, I'll give you guys some review activities similar to what we did before. And then Friday, we'll open up the assessment in Mastery Connect for the end of the unit. Mastery Connect assessment will be open for over the weekend through the middle of next week. Please make sure you take that. You only get one shot at it. It's in Mastery, like I said, it's in Mastery Connect. If you don't know your Mastery Connect info, please reach out to me, 704-363-9034, text or call. Make sure you get that info from me before this thing times out before too long. Hope you guys are having a great day. I hope you guys are staying safe out there. Remember, we're approaching the end of phase 0, effectively, of quarantine. So we'll be seeing what's going to happen on the 8th with phase 1, with limited things starting to pop back open. We will not return to school this year, but they still don't want huge groups of people getting together and getting within that 6-foot distance. We're still going to maintain our social distancing. So make sure you pay attention to that. But as we go into our last day of classwork here, we start reviewing for the assessment. So 8.E.1.4 Hydrosphere, we're talking about water treatment. And our statement says, I can explain why water needs to be treated to be drinkable. So can we drink all water that we run across? No, not without a death wish. Let's start with the largest bodies of water on the planet. Can we drink ocean water? There's just salt in it, right? Well, salt is a different word in science than it is at the dinner table. So salt in the ocean is actually many different chemical compounds, kind of combined together to give us the level of salinity that's in the ocean. But no matter what combination of chemicals it is, it gives us that salinity in the ocean. Consumption of that salt water will lead to excruciatingly unhappy death for you. Your body has to use more water than you drink to flush out all those extra salts that you've consumed in that water, to get them out of your body. You can't keep that kind of salt in your body. It literally dries you out. So if you drink seawater, you'll dehydrate yourself to the point of death within a day or so. So it's not a good idea, because your body will suck water out of your cells and all the other water-containing organisms in your organs in your body to flush that salt out through your kidneys. And in doing so, you will dehydrate yourself to the point of death in very quick measure. So drinking seawater is not a way to maintain yourself. So if you had going forward, so if you had an actually glass of absolutely clear, odorless, tasteless water, it might seem safe to drink, right? No funny colors, tastes good, smells like nothing, but you might die if you consume it without testing. Just because water is clear and doesn't smell and tastes good doesn't mean there's not stuff in there that will end your life in a slow or quick, painful or excruciating manner. So there can be bacteria in it. There can be a number of chemicals that are odorless and tasteless that again can lead to fairly quick death if consumed in a significant amount. So this is why you don't drink from random bodies of water. You should only drink water that you know the source of: tap, fresh rainwater. Even fresh rainwater does have some drawbacks. Everybody's heard of acid, the term acid rain. So rain can pick up certain things in the atmosphere that will lead to it actually not being that healthy to drink, even if you're literally drinking it as it falls out of the sky. So unopened, within date bottled water, that's good stuff. But old bottled water, guess what? Those things aren't sealed to the point where they're going to last forever. So bottled water that's been laying around for a couple of years, you don't drink that. Feed it to your plants, throw it in the yard, pour it on the dog, but don't drink it if it's been laying around too long, because even quote sealed bottled water will develop things in it over time if it's laid around long enough.
So the reason we stick with these is they're very few natural sources of potable water. Remember, potable means is clean enough to be able to be consumed safely. Because these natural supplies of water are insufficient to meet the demand of humans, we've developed ways to treat water and make it potable. Here in Charlotte and in the surrounding areas, our drinking water comes from local lakes and rivers. This water is not simply pumped in your house, it is cleaned first. Jump over here to the map. So in Charlotte, since I live in Charlotte, this is where I know where the stuff is. You got to go over here to Mountain Island Lake. And here's one of the intakes for Charlotte's water supply. There's the aerial view of it. So you see this little thing right here. Actually, a friend of mine has a bass boat. I went fishing with it one time. We actually drove up to this thing. But this little facility right here is the water intake for the entire city of Charlotte, right here. So this is where the lake, it just has these tubes that go down into the lake, and they just suck in lake water into this facility, and then it is pumped. There's another intake right here. There's two of them. There's the older one, and then there's the newer one. But these intakes here are pumped. You know, here's the pump building. Here's the electrical station that supplies electricity to the pump building, and it's pumped to this facility over here. A little bit. So you see these, you know, here, there it says right there, Charlotte Reservoir. It's pumped into these things, and here's what's happening to it. So as you take the raw water, first thing happens, and this, I took this chunk from the CDC's website because it explains exactly what the our standard from North Carolina, Department of Instruction says. So drinking water. We gotta get rid of, stuff that's in the water. We gotta get rid of germs and everything else. So first thing is coagulation and flocculation. Coagulation and flocculation are often the first steps in water treatment. Chemicals with a positive charge are added to the water. The positive charge of these chemicals neutralizes the negative charge of dirt and other dissolved particles in the water. When this occurs, the particles bind to the chemicals and form larger particles called floc. So flocculation, there it is. This right here. So coagulation, those things get together. You kind of stir it around. It causes those chunks to bind together. You pump this into a thing called sedimentation. So we go back to so the water's first pumped into these these big lakes right here. As it sits in those for a while, a lot of times a lot of junk just kind of settles at the bottom of those. So then it's pumped in, down here into this facility. You can see all these open bodies of water being treated. So these are the tanks. They're open air where this water is being had. Things are doing to it. So it's one process, and then after it's filtered, goes through, gets pumped into these tanks, and from those tanks it goes out. So you have the coagulation, flocculation, sedimentation, filtration. Sedimentation, the floc settles the bottom of the water supply due to its weight. This settling process is sedimentation, just like in sediment, forming a sediment. Well, all that stuff just floats, sinks to the bottom, and then they take the water off the top of it. And then once the floc has settled out, we pump the water off the top, and we filter it. Clean water will pass through filters of varying compositions, sand, gravel, charcoal, and pore sizes. The smaller the pore size, the more stuff it catches in order to remove dissolved particles such as dust, parasites, bacteria, viruses, and chemicals. So there's our water coming in, goes through all these processes, filtration, disinfection, which is the next step. After the water's been filtered, a disinfectant, chlorine or chloramine, one of the two, chlorine, just like you put in the pool, but they put chlorine in the water, may be added in order to kill any remaining parasites, bacteria, and viruses, and protect the water from germs once piped into businesses. So that all occurs in that plant that I was showing you on Google Maps right here. So all that water, the entire city of Charlotte's water supply comes through right here. And this is where everything gets filtered out of it to make it clean enough to drink. It's pumped into these tanks, and from those tanks, it is distributed all over the city of Charlotte. All over. I think this plant is rated at 126 million gallons per day. 126 million gallons of water per day it can filter. It's a lot of water. Once that water gets pumped to your house, you use it. You're brushing your teeth in the sink, washing your dishes, or going to the bathroom, whatever else. And then all that water leaves your house in the sewer lines. We don't just dump that stuff into the water either. It literally goes through almost the identical process again at a wastewater treatment facility, such as this one up off of Mountain Creek Road. So it's given again, given a dose of stuff that makes all the solids in it, clumped together, pumped into these tanks, these ponds here where it settles out. Settling ponds, it's kind of aerated out. They get all the junk out of it, pump the solids out, treat the water again, and then this particular facility puts water into Mountain Creek. So the water that comes out of here, it goes in as sewage, not something you pump into the ocean or waterways. It comes out clean enough to put it in the creek and nothing happens. So there are a number of these facilities around Charlotte, and that just happens to be the one that's closest to my house. But that's how we deal with clean water. So we pump it in, we clean it, drink it, we use it, flush it down the toilet, gets cleaned again in almost the identical way. You get all the junk out of it, and it goes right back into the water system for the next community down the road to pull it out of the water, clean it, and filter it, and send it to their people again. So that's what we do to have clean water in the United States. Because water is essential to life. Water quality determines the health of not only the people but of the ecosystems they occupy. Human activities are some of the main threats to our water quality, which is why our government maintains organizations that monitor water quality. Both the state and federal governments have divisions dedicated to protecting our water, because without clean water, our ability to sustain life in all categories diminishes greatly. So, both the state and the feds have departments that their sole job is to monitor and maintain water quality and make sure that people are complying with the rules, that you're not dumping stuff into the waterways, you're not polluting other ways. This is just the surface water. So if we go into like well water, you're like, well, some of you actually might be living on a well. Nothing wrong with that. My mom lives on a well up in New York, but well water can be polluted just as easily as surface water. For instance, down the hill, because my mom lives up on the side of the hill, her well water, is flowing downhill from further up where she is. It flows down towards the side I'm about to talk to. A guy back in the 60s, when they first started, IBM started making computer chips up there, bid for the business of cleaning the trays that they carry these things around on. So he would take these things back to his house, and in the basement of his ancient, house built in the 1800s. It was an old house. He would clean these with chemicals and just flush that stuff into a open drain that just led down into the ground. It didn't go into a sewage. It just went into the ground. And over time, all those chemicals seeped down through the ground and contaminated the groundwater underneath his house. So then they had what they call a plume. So as the groundwater underneath his house got contaminated, that stuff started flowing outward from his house. And people started getting ill from drinking well water in the area. And at first they thought it was IBM. And so, they started suing IBM, you're polluting the groundwater. And they're like, no, it's not us. It's, they were testing the water on the plant. And yeah, some of the contamination had reached the plant, but they're like, wait, they could tell by the way it looked that the that the plant wasn't the source of the pollution. So they hired, so IBM in defense hired a bunch of guys to go trace the source of the pollution. And they traced, they drilled wells all over the place and tested water out of all of people's wells that already existed. And they finally figured out that the center of the source of pollution was this dude's house, and that's where it was coming from. And then they backtracked, why in the world is it coming from this house? Because the guy that was doing that, he was long gone, and somebody else lived there. And and what they found out was that, they figured out that he had that business operated out of there, and they found contamination in the basement of the home that matched up with the contamination of the groundwater. So they finally figured out, they looked at the previous owners, and they finally found the connection between the guy that was cleaning those trays and early IBM. So IBM ended up kind of being at fault anyway. And since that dude, that business was long gone, I think the man had passed away. It was like a 1 or 2 man business anyway. So IBM ended up being kind of liable for it anyway, but not nearly in the way that everybody thought. IBM didn't pollute the groundwater. They hired somebody as a subcontractor who they didn't monitor, who ended up polluting the groundwater. So, but the groundwater got polluted. It's still polluted to this day. And you can't drink the well water down in the valley below my mother's house. But my mother is upstream of the point of pollution, so her well water is fine. Just as so there are very, very good reasons to pay attention to the water quality, because poor water quality can lead to illnesses. And when it's something like this, the illnesses aren't everybody doesn't have the same thing. This person's got, has this issue, this person has that issue. So you have to have a bunch of people getting very ill with seemingly, unconnected things before people start going, hey, wait a minute. You have this whole cluster of things of people being sick. Maybe there might be an overlying reason for them being sick, even though they're all not sick with the same thing. So it takes a long time to figure that kind of stuff out. And that's why it's so insidious to, water pollution. But anyway, so our last day of actual new instruction for this unit, Wednesday, Thursday, we'll be reviewing. Friday, we'll be assessed. We'll open up the Master Connect. If you have any questions or anything, please give me a text or call 704-363-9034. And like I said, I'll drop all your review stuff in there for the rest of the week over the next couple of days. Hope you have a great rest of your day whenever or wherever you are. And like I said, only a couple more days before we are start lifting some of the restrictions that we've been living under. Okay. Yeah, I'll have a go.